Hello, my name is Kara Phillips, and I'm excited to talk to you today about Apex Gamma variable geometry. Apex Gamma with LabSOCS variable geometry is really an integration of three powerful products that you may have heard about before. Apex Gamma is our laboratory productivity suite for gamma spectroscopy, built on top of the Genie 2000 analysis and acquisition engines. While LabSOCS is a methodology to provide an efficiency calibration of our sample without the need for a reference standard. We have lots of information available about these products, but what I really want to focus on today is the concept and the implementation of LabSOCS variable geometry in Apex. My hope is that this video will help you illustrate and determine if LabSOCS variable geometry is of use to you in your operations. Let's take an example first. Here is a standard Mirion 4-liter calibration standard, which you may have calibrated in your system. However, you are provided a sample like this, which was not filled to the same level as your calibration standard. What options are available? Well, let me show you what one of those is, the new LabSOCS variable geometry. As you can see here, I've made a LabSOCS template corresponding to our reference standard. I've called this 4mb.geometry for my 4-liter Mirion beaker. And I also notice here that it has a fill height of 150 millimeters. This is the same fill height as our reference standard. So now I'm going to go switch a little bit and look at my Apex Gamma system. You may have seen this system before. Over on the left-hand side, you see a list of different samples that have been queued up. To start one, you'd simply click and drag and drop to the main interface to start a count. But to take a close look at how variable geometries look, let's look at the setup screen for Apex Gamma geometry over here. So what you may see here is that, like any classical LabSOCS geometry calibration in Apex, we have the Apex geometry associated with a LabSOCS geometry. But what's different is that on the left-hand side, we have this icon, as well as a new option to select variable geometry. And that's what we'll go to now. And this is really the key of how variable geometry enhances on a classical LabSOCS geometry. Over here on the left-hand side, you see the option to vary up to 5 different parameters: the fill height, the density, the material, the source detector distance, and the absorber thickness. And I can vary all of these or just one, as in this selection, where I have the sample fill height identified to be variable. And the part that really enhances this particular feature above and beyond other applications is the fact that you can actually identify what the minimum and maximum variable ranges are for that particular parameter. So for instance here, I have a minimum fill height of 110 millimeters, which is just above the bottom wall of a Mirion beaker, where the detector sits. And then I have a maximum fill height here of the maximum height of the container itself. But when I want to go ahead and show what the end user looks like when they want to use this variable geometry. So, like any other efficiency calibration in Apex Gamma, this geometry needs to be applied as an efficiency calibration and saved. We can go ahead and look at what that result here is if we look at my calibration that was previously applied. And I can see here now that in fact I've actually generated 3 different possible efficiency curves. I have a minimum efficiency, and this shows what the lowest possible efficiency is for all those variable parameters could be generated. I have a maximum efficiency, which is the maximum efficiency resulting from those variable geometry parameters. And then I have a default curve, which is what my original geometry template from iSOCS generated. I have many other options that I can come back to on the screen, but once this geometry is used to create a new efficiency calibration and is approved, I can use this calibration in a procedure like any other. This is what the operator sees. So when an operator creates a new sample, the steps that they follow are to first select your sample type. In this case, we have a category called variable geometry, where I've had this item populated. And I can create a new sample. For instance, I can call this new sample. I'm going to select from my procedure a procedure that's identified to use the specific geometry that I created, the same 4LMB that we referenced previously, which I've had calibrated in my system now. And when I go ahead and hit next, What the operator sees is this new screen, which is instructing the operator to enter in the particular fill height for that unique sample. So if I go ahead and measure that unique sample, I can take a ruler and I can observe here that the fill height is about 125 milliliters. So I can enter in this value into my sample fill height, select Next, and save it. Now when I go to my main screen, I can see that this new sample is populated on my list, and I can count it like I would any other. And the variable geometry is now applied to the calibration and will be used for the analysis at the conclusion of the count. Another option there as well too is the ability to change to a different matrix type. So for instance, say I received a container like this where I've already set up a calibration standard to use a water or epoxy matrix to substitute in now a different density or even a different matrix such as a soil sample. I can go ahead and use the same options that we've shown before. Remember, those are my fill height, my density, my matrix, my absorber thickness, and my source detector distance. And so these can be used together or in combination or on their own. Another feature also is that we can vary not only by a specific range, but also having a drop-down selection of discrete distances. So in the example of having a different source detector distance, perhaps you have it on shelf 1, which is 1 millimeter from the detector, shelf 10, which is 10 millimeters from the detector, and shelf 15, which is 15 millimeters from the detector. We see now that my count is complete, so I'll go ahead and look at my result. In data review, I can go ahead and search for my recently acquired count. And there's two more features here that help make the traceability of variable geometry really applicable for today's laboratory operations. So in my sample here, I can take a look at my report. My report now has calculated my activity results as I would have expected for these to be completed. This is standard for any other Apex Gamma counting application. I also now have this additional radial button for my efficiency. By selecting this, I can observe the specific efficiency that was calculated for the sample. Because in fact, when the sample was analyzed, a new efficiency was calculated at that time. And one final aspect as well too is the fill height was populated also now in my sample information. So again, as a data reviewer, I have some visibility to see the particular fill height that was applied. And if necessary, I can go ahead and change this to a more accurate value if I found that the value entered was incorrect and do a reanalyze. In addition, the use of minimum and maximum allowable parameters allow users to ensure calibration procedures are valid and consistent with target MDAs while not sacrificing usability. During efficiency calibration review and approval, the software will even display the minimum and maximum efficiency values to help with this assessment. The key of variable geometry is that it integrates the flexibility of LabSOCS with the data control and traceability of Apex Gamma. This opens the door for opportunities beyond current laboratory practices. A single Apex Gamma geometry can now be used for a wider range of samples, but perhaps even more interestingly is that a single geometry can now be used to finally represent each unique sample. This in turn drives more accuracy for your measurements. I hope you found this demonstration interesting and you found opportunity to use LabSOCS variable geometry with Apex Gamma within your laboratory.